I was very interested in the notion of machines with memory. I got given a tape recorder, I think right about my 12th birthday, and I went round explaining to everybody that it was a machine that remembered things.
I did really brilliantly at O-level English literature because I'd seen Great Expectations, not because I read the book. If I'd said that at the time, if I really admitted it at the time, there would have been teachers in my class who would have said, oh, well, of course, you only really had half the experience. You pay your money, it takes your choice.
I didn't discover computers until I was a teacher. And then one of the parents gave the school a computer. I learned a lot, and that experience just switched a light on for me. I thought, this is a good way to help people learn. And that was 40 years ago, but I stick by that.
People use, experience and interact with technologies in many different ways. But today our ambitions for education will surely not be realised without technology designed to help people learn. The aim of this film is to share a vision of how we can exploit technology to invent the future of learning. The Technology Enhanced Learning Research Programme has spent more than 4 years developing systems and software. The potential for learning is evident across all 8 projects, and the programme has addressed a wide range of themes such as personalised learning, productivity gains, increased flexibility and more inclusive approaches to learning. Each of the projects has developed systems that address pressing problems of teaching and learning. The learning designer puts in teachers' hands a way for them to explore lesson planning creatively and to capture their pedagogy intelligently. The ensemble project applies machine intelligence to help teachers and trainers find, exchange and interpret data from diverse sources. Imagine how effective group work could be if it were enhanced by giant, linked and gesture-sensitive tablets. That's SynergyNet.
The type of pedagogy that I think is going to be important for this technology is really an attitude about kids engaging in learning themselves. They're coming into a world where there is more knowledge being created than we will ever be able to teach them in school, so they need to learn how to organise knowledge for themselves, how to continue learning throughout their lifetimes.
On the Interlife virtual reality island, young people can confront the difficulties of life transitions safely and supportively. Focusing on autistic children, the ECHO system enhances communication by harnessing the power of artificial intelligence. Based on sense of touch technology, the award-winning Haptel system enables dental students to practice drilling teeth effectively and cheaply.
We've measured the evidence in lots of ways. We've used psychology tests to test them before they've used the haptics and at the end of it, and to see how their manipulation skills have improved and their three-dimensional skills. And what we found was that the students who had used just the Haptel environment did as well in treating a tooth at the end of the 3 months, even though they'd never treated a real tooth in their lives.
The Personal Inquiry Project gives learners the power to think and act like scientists, using smartphones as scientific instruments. A key stumbling block for children learning maths is when 1, 2, 3 turns into XYZ. MyGen has created a bridge to help them understand how algebra works.
While the students are undertaking this construction through the graphical environment, the system tries to also provide them with hints and nudges and prompts to help them towards a productive construction of the model. So it's trying to encourage students to explore the nature of the relationships in these graphical models and to uncover rules for themselves.
All of the projects have included input from both computer scientists and educationalists, and importantly, all of the projects have worked with practitioners from the first day. This attempt to merge 21st century technology with 21st century pedagogy had to be embedded in practice. The thinking behind this is largely based on a constructionist approach to learning. Constructionism is based on the idea that people learn best when they build things and share them with each other. Mitch Resnick, head of the academic group at the Massachusetts Institute of Technology Media Lab, explains.
I was deeply influenced by my mentor, Seymour Papert, who was the true pioneer in having a new vision of the role that technology could play in the lives of children and more broadly in the society at large. I think Seymour was one of the first people to see that technologies could be a means of expression for young people, a way for them to express their ideas and to get a new understanding of the world through their designing and creating with new technologies.
That's the real contribution that research can make, is to help us rethink what is possible for learning and teaching now that we have technology to help us do it, and how we can design those technologies to make a difference.
Pockets of good practice already exist, but it has until now been difficult to scale up the advantages that technology can bring to education. However, things are changing. Suddenly, we can take for granted that learners, both children and adults, have access to powerful consumer technologies such as smartphones and tablets. No longer is the major challenge to distribute technology to schools, colleges and workplaces. The challenge now is to learn how to design and use it effectively.
Teachers and schools have just got to get hold of the fact that mobiles are things of the modern era. They've seen the mobile as an enemy, but the idea you can somehow insulate the school from what's going on in the rest of the world and say we're going to go on like this forever, and the fact that kids have all got laptops and mobiles and all the rest of it anywhere else is nothing to do with us, I think really is putting your head in the sand in a quite unacceptable way.
The appeal of the tablet device is first its user interface, that it's so intuitive to use. Then it's its portability. It's just easy to carry around. It's light and it's agile. And then the fact that on the move you can do all these different things, which means that then you can use it inside the classroom and outside the classroom. You can extend the learning day through into home, and then you can use it in ways that we're only just starting to think about.
At Longfield Academy in Kent, every child has an iPad. As the school can take for granted simple, cheap access to technology, they can focus their attention on how to get the best outcomes for learning.
The iPad is almost a teacher. Yeah.
The iPad is almost a teacher?
Yeah.
What do you mean?
Because it's almost like a teaching assistant. Because the teacher will put a task on the board saying, write down everything you know about the Bangladesh earthquake.
Yeah.
And we'll be like, we don't know anything about it. You've never taught us about it. And she'll say, well, go and find the information. Yeah. And then we'll write it down.
I think it'll take us to a combination of the interactive whiteboard, skillfully used, and the tablet, iPad or whichever it might be. And I think the combination of those linked together will ironically mirror where we started 130 years ago with the chalk blackboard and the slate.
And yet, despite the growing awareness and the dedication to technology shown in many schools and universities across the country, there remain voices of concern about our wider educational relationship with technology. One concern is that our current pedagogy is often stuck in the 19th century, desperately trying to catch up with 21st century technology.
Whiteboards may have eliminated chalk dust, chairs may have migrated from rows to groups, but a teacher still stands in front of the class, talking, testing, questioning. But we all in this room know that model won't be the same in 20 years' time. It may well be extinct in 10.
Film industry is very simple. If you were an editor in 1997, a phenomenally successful editor, cutting film, and were still trying to get a job in 2007, you were unemployable if you hadn't made the transition. Now, so it wasn't a question of sitting around saying, I'm not sure whether I'll do it or not. You had two choices, retire or learn. And in a sense, the teaching world and education generally hasn't been confronted with that kind of stark reality.
At the same time, many are beginning to recognise that we all have to know something about how computers work. We all have to be aware of what's under the bonnet.
I was flabbergasted to learn that today computer science is not even taught as standard in UK schools. Now, your IT curriculum, by the way, focuses on teaching how to use software, but it doesn't teach people how it's made.
In the 1980s, we had ZX Spectrums and BBC Micros. Those were programmable computers. And what that meant is that everybody who had an aptitude for it, everyone who might have an aptitude for it, had a chance to discover that aptitude and develop it. We've kind of fallen away a long way with games consoles and PCs. We've fallen a long way from there, so that we know there are children out there who want to learn to program. We know that there are children out there who have an aptitude for programming.
Becoming a computer programmer is something that most people won't do. Just like most people won't become authors or poets. But that doesn't mean that they shouldn't read books and read poetry.
Well, I would like to regard programming languages as being like other languages. There's research that shows us that bilingualism or more is a good thing, learning extra. And I would like, it seems to me that learning programming languages young would be a good thing to do.
Absolutely everybody needs to know what it means to write a program and what the components of a program are. I think we have a fantastic opportunity now that we haven't had before. We have programming languages that are really tailor-made for learning.
Ever since the late 1960s, when Seymour Papert and his colleagues invented the programming language Logo, educators have recognised the need to build programming systems that were good for children, in fact, good for everyone. A recent example is Scratch, developed at MIT and adopted worldwide by learners of all ages, inside and outside formal educational settings.
I think it's a massive step away from an office-based curriculum, which is kind of what I feel it has been for a very long time. I did A-level ICT and I learned how to make an Access database, and it was the most depressing 2 years of my life. They can see how things work. They actually are starting to get an understanding of how a computer game is made.
So you're like building a game on the computer, are you?
Yeah.
Okay, do you play a lot of computer games yourself?
Not really.
No?
I'm not a fan of computer games.
I sometimes make the comparison, of a stereo versus a piano. In some ways, both of those can be seen as tools. They're both technologies. But I would prefer the young people grow up learning to play the piano rather than learning to play the stereo. But I don't want to be limited to just consuming through the technology.
We have recently seen the launch of the phenomenally successful Raspberry Pi computer, and here its designer, Eben Upton, explains the thinking behind this device, costing just £20.
Just like the machines in the 1980s, this uses your television, which is still often the most valuable piece of consumer electronics in a household. This uses the television as the display. You plug a USB mouse and keyboard. You have to scrounge up a USB mouse and keyboard from somewhere, but people can often do that. It uses a mobile phone charger as its power supply. So the idea here is to use things that people already have in their homes. There's not much point in making a £20 computer if people have to go and buy £100 of hardware in order to use it. You plug it into those devices, you turn it on, it boots up, and you can start programming straight away.
So programming is one way in which people can express their ideas and share them with each other. But, as we've seen in the TEL research programme, an equally powerful approach consists of carefully designing and building power tools that target specific problems and difficulties facing learning and teaching today. These difficulties will get greater as the amount of information available to us continues to explode. Here is where artificial intelligence can have an impact.
Artificial intelligence is a way in which we develop technologies that can behave in what one would consider to be an intelligent manner. We have information available to us most of the time, most of the places we are, and in multiple forms. And that's a huge benefit for supporting learning. We are surrounded by information, and very rich sources of information: pictures, films, text, audio, even tactile information about how things feel. And that is fantastic, but it's not the same as knowledge and understanding. So there are many ways in which artificial intelligence techniques can be used to help us make more sense of this huge amount of information that we have around us, and help us turn it into a real understanding and a real knowledge that will move us forward as individuals, as groups, as nations.
Whatever the future holds, it will not be enough to hope that technology develops in helpful directions. It will need research, and it will need design.
Well, design is essential. I mean, you can't, you won't have access to anything usable unless it's designed. So there isn't a question of does one design. The question is, what is the quality of the design?
I believe that the key issue is for the research community to understand better what the decision-taking timetable is for government, and for government on the same, or by the same token, to understand what it is that research can offer. In the field of technology, this is truer than in any other area, because it's critically important, as the technology capacity increases all the time, that government understands what can be done.
There's a very dramatic clip in Warhorse where there's a cavalry charge, and at the moment the covers come off the machine guns, the horse moves from being an asset in a battle to a liability. And that, I think, it is that dramatic. I think that out there we actually have created, not necessarily in one instrument, the machine gun, we have created the equivalent of educational machine guns. We haven't deployed them.
We haven't really had time yet to rethink what becomes possible with technology. It's been such a short moment in time since almost everybody had access to powerful technology. So the real challenge is to think deeply about what it becomes possible for people to do, what it becomes possible for people to learn, that simply wasn't possible with the old technologies. That's not to throw away all that knowledge, accumulated knowledge of pre-digital technologies, but it's to say the technology makes it potentially possible for people to learn things that were hitherto unlearnable, and for teachers to teach what was hitherto unteachable.